Hello, welcome to this session. In last two sections, we discuss about charging and discharging problem of a circuit. If we have RC network in any circuit and if we are connecting that network with a battery, and what would be the charging and discharging profile of a capacitor that we have already discussed in the previous two sections. Now we will solve this problem. In the mm, in the last section, two section back, we have already discussed the problem. Actually, we have not solved this problem, but we have gone through the RC network circuit. I will explain again what is this problem about. This problem has a circuit where 20 ohm resistance and this is in series with the 40 ohm and C is equal to 0.5 micro coulomb capacitor. This capacitor and resistors are in parallel, and what this question is asking is like what would be the maximum current, or you can say I naught current in this circuit at t equal to 0. Okay, and then after a longer time what would be the current, and then the total charge accumulated in the circuit. And finally is asking if S is opened again, means after charging this capacitor, if you open this circuit again, then what will happen, when after what time, how long will it will take to discharge this capacitor by 80%. Okay, means only 20% charge will be remaining, means after what time, this is what it's asking. Okay, then start with the first problem, means the one problem in section A. Section A, I naught leaving the battery at t is equal to 0, leaving the battery at t is equal to 0 immediately after the switch is closed. Switch is closed at t is equal to 0 means switch is closed at t is equal to 0 means this. See, this at t is equal to 0, t is equal to 0, this switch will be closed at this time. Okay, means then current will start flowing. I have already discussed that once switch will be closed, then what will happen at that time, whenever switch is closed, this resistance path of this will be zero resistance. This cap will work as an ideal conductor at t is equal to 0, and then it will start charging. Once it will get full charged, what will happen, the current will not flow through this, means this will be open circuit then. Okay, so at t is equal to 0, when there is no charge at that time, R is equal to 0. Once it will get fully charged, then R will be infinity. Okay, means at t is equal to infinity, R is equal to infinity. At t is equal to 0, R is equal to 0. You can take in this way for simplicity. So t is equal to 0, that is the thing, and at t is equal to infinite means longer time. Sorry, at t is equal to infinite, this color is not good, man. Choose some different color. Yeah, at t is equal to infinite means longer time, R will be infinite. R of what? Not other R, only this C, means the reactant of this. I'm talking about this and this, not the regular R. Okay, now what is asking, I is equal I naught, current I naught, leaving the battery at t is equal to 0 immediately after switch closed. Okay, switch closed means R is equal to 0, means current will pass through this at t is equal to 0. All current will pass through this because there is zero resistance path and no current will flow through this. Okay, then you will have a resistance in this circuit like this 20 ohm, and that's it, right? Current will not flow through this because this is already shorted, right? Then what will happen at t is equal to 0? at t is equal to 0. That's something wrong. It's very slow. Okay, I will be equal to, means your I naught will be equal to E by R, E by 20. That's it, E by 20. Your E is 10 and this ohm resistance is 20. E is 10, so 10 by 20. 10 by 20 means 1 by 2. 1 by 2 ampere. 0.5 ampere. Okay, this is I naught. And what is the current at longer time? Means at t is equal to infinity. When you have t is equal to infinity, infinity means longer time, then your r, this r will be 0, right? This r, oh sorry, this r will be infinity. I'm very sorry. This is not 0, this is infinity, means higher value. Okay, so this r will be infinity, very high resistance path. Then current will not flow through this path. Current will not flow through this path, means through this path. This is means open circuit. Current will flow through this. Then total resistance of this path will be 20 plus 40 means 80. The total R equivalent R equivalent will be equal to your R1 plus R2 means 20 plus 40 plus 40 means total 60. Okay, now total I current I will be equal to, in this case, your 10 by 60 means 1 by 6 ampere. 1 by 6 ampere. Right, done. Second is done. What is the charge? What charge has accumulated on the capacitor after long time? After long time, what will happen here? Here you will have some potential drop, right? The potential drop at this point at t is equal to infinity, means longer time means infinity, right? At this point, we'll calculate the current at potential difference at this point. Okay, this point let's assume A and this point is B. Okay, the potential difference between A and B will be same as this. Then you have a V, you have C, you can find out Q. The Q will be equal to, Q is equal to actually CB, right? Only thing you need to find out is the potential difference between this. You know the current 1 by 6, you know the resistance here. The total current I is flowing through this. Total current I means after infinite time. After infinite time, this current is flowing. Then you will get the V, value of V. I'll calculate with some different color. The V at AB will be equal to a regular current. A regular current means this I into R. That is I is 1 by 6 into R into R is 40. Okay, then then this will be equal to 20 by 3. 20 by 3. Now you have C. C is 0.5 micro C. C is 0.5. I will put this value over here. I'll put this value over here. This is nothing but 20 by 3 into 0.5 microcoulomb. 0.5. 0.5. It means the total, it will be equal to means 5 to the 10 means 10 by 3. Okay, 10 by 3 microcoulomb. Okay, that is the microcoulomb is a charge, right? This is nothing but microfarad actually. Here it should be microfarad. This is because it's a capacitor, right? Okay, then you got this answer. And last one, if finally switch is open again, what will happen? If switch is open again, then this is totally disconnected, right? The only closed loop will be this one. So I will just redraw the closed loop. Closed loop will be this. You have a capacitor connected over here. Here you have 40 ohm resistance. 40 ohm resistance, okay? And here you have a capacitor where you know the total charge. Total charge is 20 by 10 by 3 micron. You know Q naught 20 by 3. 20 by 3 and fine. And we need to find out 80% charge. After the switch is open, how long will it take after the switch open for the capacitor to lose to 80% charge, right? Means at any point the charge will be Q naught e to the power minus T by RC. You know the value of C here. C is 0.5 microfarad. 0.5 microfarad. Okay. Now, you know this value, you know R value. R is 40. The total RC, value of RC will be equal to, this is C, value of RC will be equal to 0.5 into 40 means 2, 20 micro. R and C, so micro into 10 to the power minus 6, 10 to the power minus 6. Okay, that is RC. Now Q is equal to Q naught means we need to find out 80% discharge, means remaining charge will be 0.2 Q naught 0.2 Q naught will be equal to Q naught E minus T by RC. We already know RC value. Okay, we already know RC value. Q naught will get cancelled.